And welcome back, and it is the 27th of Feb. It is the 5-a-day further maths, and let's just go straight into the first question. Right, so what do we have? So we have an expand and simplify. Now, I'm sure none of you would do this, but of course the point is here that I need to expand brackets as I would normally, and that just occurred to me because I've read the question correctly, that is a cubed, not a squared. So this is going to be especially annoying, but either way, let's just do it step by step. So 5 root 2 minus 1 times 5 root 2 minus 1. I'm going to deal with one bracket first. So 5 times 5 is 25, and root 2 times root 2 is 2. 5 root 2 minus 1 minus another 5 root 2 is going to be 10 root 2, and minus 1 times minus 1 is plus 1. Let's collect some of these things first. So that's going to be 50 plus 1. So it's going to be 51 minus 10 root 2 times by 5 root 2 minus 1. Right, and then I'm going to come up here. 51 times 5 is going to be 255 root 2. Wow. 51 times minus 1 is minus 51. 10 root 2 times 5, or minus 10 times 5 is minus 50, and root 2 times root 2 is 2. In other words, that's 100. And minus 10 root 2 times minus 1 is plus 10 root 2. And let's collect all of these things together. So 255 root 2 plus 10 root 2 is equal to 200, and this is my final answer. So 265 root 2. And then minus 51 minus 100 is minus 151. That wasn't where I thought that was going to go, but nevertheless, not too bad as a question, just taking it carefully. Next question. Oh, got combinations. Well, I had combinations yesterday. It feels like there's a few coming up. Jason picks a 5-digit number. So there we go. So there's 1, 2, 3, 4, 5 digits. That is less than 80,000, which obviously has 5 digits as well. If it's less than 80,000, well, actually, let's carry on. The first digit is odd. The fourth and fifth digits are equal. How many different numbers? Right. Okay. If it's less than 80,000, the first digit is odd. That digit can only be 1. And by the way, I presume it can't be a 0, and 0 isn't odd. And let's just assume that's not the case because it gets annoying otherwise. So the first digit can be 1, 3, 5, or 7. So there are 4 choices of the first digit. It is not the case that digits have to be different because it doesn't tell me that anywhere. It also doesn't tell me the digit itself is odd, just the first digit. So therefore, in other words, this digit here can be any one of 10 digits. And this digit here can also be any one of 10 digits. And this digit here can also be any one of 10 digits. But the fifth digit is the same as the one I've already chosen. So therefore, that can only be one choice. So multiply all these together. 10 times 10 times 10 is 1,000. So my answer is 4,000 different digits. Question done. I like those questions. Okay, the nth term of sequence is 1800 minus 9n over 1800 plus 2n. Write down the limiting value. So what's going to happen here, and a comment I often make, once you get to do A-level, especially further maths, you do a lot of limiting stuff, working out what happens when n gets very, very large or very, very small. In this case, you can actually just, no, it's not cheating, is it? But you can just get your calculator out and just put in an incredibly large number, like a trillion or something. But the point is, what will happen is, let's say n was a trillion. Well, 1800 minus 9 trillion is pretty much 9 trillion. In other words, 9 big numbers. And 1800 plus 2 trillion is basically just 2 trillion or 2 big numbers. So as n gets larger and larger, this is just going to approach 9 over 2. Now, when you get to A-level, you write lots of language about n approaching infinity and limiting process and stuff. But for here, you could just write down minus 9 over 2. It's fine because it's a one-step calculation. Next and final question today. We've had a few of these in the last few days, and they've been quite complicated. We've had to work through them slowly. So let's read the whole thing first this time rather than just jumping in. So it gives me an equation, y equals something, where p is a constant. It's just a whole number. Not a whole number, a real number. And then it says when I differentiate and x equals 3, it's 5 times when x equals minus 1. Okay, so we're just going to set up an equation and solve it, aren't we? So first step is we're going to work out dy dx. So dy dx is equal to 8x plus p. Now at x equals 3, that's to 8 times 3, which is 24 plus p. And at x equals minus 1, that's to minus 8 plus p. Then it tells me the value of the first one is 5 times the second one. So in other words, 24 plus p is 5 times bigger than minus 8 plus p. We've got one equation, one unknown, so we'll just solve this, can't we? So therefore 24 plus p is equal to minus 40 plus 5p. Take away p from both sides, which gives me 4p. Add 40 to both sides gives me 64, which means that p is equal to 16. Not terrible, nice little end. Not as bad as the last few days, but equally a good question to end on. Again, nice mix of questions today. I quite like the combinations question in the middle. Limiting process question, it's just one of these that it's quite straightforward at GCSE further maths, but gets a lot harder when you do A-level. But yeah, let me know how you did. Put how you did in the comments, please. Always good to read. And do like and subscribe. Really appreciate that. Thanks all.